Welcome to the Explainer. If you're studying for that AWS Certified Developer Exam, you absolutely know you're going to get hit with questions about deployment artifacts. So today, we're going to break down everything you need to know about them, from managing dependencies to packaging it all up, so you can walk into that test feeling confident. Let's do it! Oh man, we have all been there. You hear those 6 little words, but it works on my machine, and your heart just sinks. You know you're about to lose the rest of your day debugging. That one sentence is exactly why this stuff matters so much. It's not just for an exam. It's about how we build software that actually works for everyone.
So, to finally put that phrase to rest, our journey has to start right where the code gets written, on the local machine. This is where we lay the groundwork for deployments that are predictable and, not a total surprise every time. And the key concept here is creating what we call reproducible builds.
The idea is actually pretty simple, but it is so powerful. A reproducible build means that if I take your source code and my teammate on the other side of the world takes your source code, we should both get the exact same result. I mean, bit for bit identical. This is really the foundation of having any trust in your software deployment process.
So how does this even happen? Your build works perfectly on Friday, you come in on Monday, haven't touched a single line of your own code, and boom, it's broken. What's the deal? Well, a lot of the time, the culprit is an external dependency. Maybe a library you depend on pushed a new version with a breaking change, or even worse, it got temporarily pulled from a public registry like NPM. It's enough to drive you crazy.
And what's wild is that sometimes all of this risk comes down to a single character. See that little tilde or that caret next to the version number? That's basically you telling the package manager, hey, go ahead and grab a newer version if you find one. It's a total gamble. The fix? You got to pin your dependencies to an exact version. That is step number 1 to a sane, reproducible build.
Now, lock files take this whole idea to the next level. See, they don't just lock down the libraries you listed in your package.json. No, they create a perfect, complete snapshot of your entire dependency tree. That includes the dependencies of your dependencies, and so on. This is your ironclad guarantee that my machine, your machine, and the build server are all using the exact same code. And here's a big one for the AWS exam, so listen up. You need to know your tools. AWS SAM, that's the Serverless Application Model, is built for this. When you run a simple command like SAM build, it does all the heavy lifting for you. It reads your files, it resolves all the dependencies, and it packages everything up perfectly for services like AWS Lambda.
Okay, so we've stabilized our local environment. That's great. But now we have to push that code into a build pipeline. And this is where the ghost of "it works on my machine" really comes back to haunt us, because the tiny differences between your laptop and the cloud can cause some major headaches.
Let me paint you a picture. Let's say you're on your shiny new Apple Silicon Mac, and you compile a native C++ library. Well, you just created a binary for an ARM64 architecture. But guess what? The Amazon Linux environment waiting for you in the cloud is probably running on x86-64. That binary you so carefully built, it's completely useless over there. Your build passed locally, but your deployment is dead on arrival.
And this is exactly the problem that Docker was invented to solve. It's the industry standard for a reason. By packaging your app inside a container, you're bundling everything, not just your code, but the runtime, the system libraries, all of it, into one single portable thing. It completely erases that gap between environments.
All right, so now we have a consistent build environment. That's a huge step. The next thing we need to think about is optimizing the artifact itself for size and speed, and of course, how we're going to store it securely.
I just love this quote because it perfectly nails a super common mistake. If you just grab a massive base image like no.latest to run your tiny little application, you're basically doing this. You are shipping a mountain of unnecessary stuff, and it's going to slow down your deployments and jack up your storage costs.
The really elegant solution to this problem is something called a multi-stage build. Just think of it as a 2-step process. First, you use a big, beefy builder container that has all the tools you need to compile your code. Then, once that's done, you start fresh with a tiny minimal production image and you copy only the finished files into it. All that other build time junk just gets thrown away.
And I mean, the results are just staggering. Look at these numbers. A multi-stage build can shrink your final artifact by over 95%. In the real world, that means your deployments are way faster, your services can auto-scale quicker, and your storage bills are a whole lot lower.
So, once your artifact is built, where do you put it?
Well, for all your internal private packages, you need a secure home. That's exactly what a service like AWS Code Artifact provides. It's crucial for protecting your code and preventing these nasty dependency confusion attacks, where a hacker could trick your build into grabbing a malicious public package instead of your real private one. So, how does a pipeline securely pass that artifact from one stage to the next? Well, a really common best practice is to use Amazon S3 as a sort of secure Dropbox. The build stage uploads the finished artifact to a totally locked-down S3 bucket. Then, the deployment stage, which has very specific permissions, is the only thing that can retrieve it. It creates this really clean, secure handoff.
All right, let's wrap this up by covering some specific best practices for deploying right on AWS. You're going to want to pay close attention here, because these are the kind of nitty-gritty details that pop up on the certification exam all the time.
This one is a classic. I can almost guarantee you'll see a question like this. It is a total anti-pattern to bundle the AWS SDK inside your Node.js Lambda package. Why? Because the Lambda runtime environment already has it built in. Including it just makes your package bigger, which makes your cold start slower, and it's completely redundant.
So what happens if you hit that 50 megabyte upload limit for a Lambda function? Don't panic. Here is your checklist. You need to hunt down and remove any dev dependencies, documentation, and test files. None of that stuff belongs in a production artifact, and getting rid of it is the absolute fastest way to shrink your package size.
And just remember, different AWS services expect different things. While a Lambda might take a zip file or a container image, if you're deploying a Java app to Elastic Beanstalk, you're going to need to give it a standard WAR or jar file. Know your target environment.
So you did it. You created this beautifully optimized, reproducible artifact, and you deployed it to the cloud. That's a huge accomplishment. But it also opens up one last, really critical question. How secure is your supply chain? Are you absolutely positive that none of the dozens or even hundreds of hidden dependencies you just deployed have a vulnerability? Well, that's a pretty deep topic, and one we'll have to save for another time. Thanks for watching.